Good morning everybody and welcome to a new video about Xamarin. This time we will talk about Xamarin.Forms. Before we go on, one thing I want to tell you is that there is so much to say about Xamarin.Forms, so make sure you visit the official documentation at developer.xamarin.com. It is the place where you can find all the topics and all the explanations about any possible scenario with Xamarin.Forms. The core of Xamarin.Forms is sharing code. By sharing code, we mean sharing the user interface and sharing code that is not platform specific. Let's see how it works. I'm going into the new project dialog. I select the cross-platform node and then the cross-platform app, Xamarin.Forms or native template. The goal of the sample application is very simple, is showing how to create a web browser application that will run on Android, iOS and Windows. I'm calling this project like Cross Xamarin Browser. Visual Studio is going to ask me what kind of template I want to use. It's okay for me to use a blank app. Master detail is a more complex template and will generate a user interface with the master detail page and some sample data. UI technology is certainly Xamarin.Forms, and the code sharing strategy is portable class library for now. The difference between a portable class library and a shared project, put succinctly, is that the portable class library will generate a DLL library. It can be used outside the solution, but it does not allow using preprocessor directives with environment variables. The shared project instead has the same goal of sharing code between projects, but it basically lives inside the solution it belongs to. It doesn't generate a compiled DLL, but it allows you to write platform-specific code by using preprocessor directives. Let's click OK, and let's wait for the solution to be created. Visual Studio will ask you to specify the Windows 10 versions for the UWP project. You can leave the default selection and then press OK. So as you can see, the solution is made of several projects. You have portable class library projects. This is the place where you will write all the user interface and where you will write all the code that can certainly run on all the platform-specific projects. Then you have an Android project, exactly the same type of project you saw with Xamarin Android. The same for an iOS project, the same project type as for Xamarin iOS, and a Universal Windows platform project. All of these projects have a reference to the portable class library project. The user interface in a Xamarin.Forms application is made of XAML markup. XAML stands for Extensible Application Markup Language, and you should be familiar with this kind of markup if you have built applications with WPF, Universal Windows Platform, or even Silverlight in the past. Now let's write some easy markup. Here you can see there is a content page object here. All the user interface in Xamarin.Forms relies on the concept of page. There are different pages available in Xamarin.Forms. Content page is the simplest form of page, but there are also pages such as the tabbed page, the carousel page, the master detail page, and the navigation page, and the latter provides the infrastructure for navigating between pages. The user interface is organized within layouts, which is not a new concept, of course. For example, we can create a grid and divide the grid into 2 rows. All right, and we can give the first row an 8, such as 50. In the first row, we can place another layout, which is called a stack layout, which is the equivalent of the stack panel for Universal Windows and WPF. Orientation horizontal. Here we can place a label with text, enter URL, and then we can also specify some properties such as the font attributes, which is bold. Then we can use an entry control. Entry is the equivalent of a text box in other platforms. I give you a name here and I call this URL text box. I'm also going to supply a width. In Xamarin.Forms you do not have width and height, you have width request and height request. For example, 100, and then we have a button called xname go button. Text is browse, and then you can specify a clicked event for this button. All right. Okay. In the second row, we have a web view control, which is placed like this. Okay, we can specify a name, such as web browser. And then we need to handle the clicked event in the code behind, in the C# code behind. Okay, we can write some very simple logic, such as if URL text box text is not null, let's simply select web browser.source equals new URI text box text. Okay. The web view control allows you to display any HTML content. Great. I can just select the startup project. The same concepts that we saw about setting up the Mac for iOS development with Xamarin iOS also apply to Xamarin.Forms. Let's start the application. Okay, now if I write a URL here, such as this one, and I touch browse, here we go. Our sample application is working, but the very interesting thing is that I can run the same application on a different device and different platform. Let me just select UWP. Then I can select a local machine, the tablet simulator, a remote machine, a physical device, or a phone emulator. Let's select the simulator. And as you can see, my application is running on Windows 10 with no changes at the code. Okay. Now, of course, there is a huge number of controls available, of layout available, and and you can use different kinds of page to arrange the user interface. But the basic concept is that everything you want to share resides inside the portable class library project. Of course, Xamarin.Forms gives you an option to invoke platform-specific code, which is code that you cannot call from the portable class library directly. Remember that inside the portable class library there is only the code that can be shared across multiple platforms. In order to call platform-specific code, and in order to show how this can happen, I'm going to use a different project I already set up. You define an interface object inside the portable class library. For example, here I have an interface with a method that will be responsible for sending an SMS. Then, inside each platform-specific project, I'm going to write a class that implements the interface. and that calls the platform-specific APIs. What I have to remember is that I must decorate the namespace with the assembly attribute passing the dependency class and the type of the class that is implementing the interface. Just for your convenience, I'm going to show the same implementation on iOS, where you can see another class that implements the aforementioned interface, and that is calling the iOS specific APIs. Another easy way to call platform-specific code from a portable library is using plugins. You can find plugins with NuGet. Most of their names begins with xam.plugin. For example, if you want to check the availability of network connection, you can use the xam.plugin.connectivity plugin. You install this library to all the projects in your solutions. Okay. Then each plugin usually exposes a singleton class that provides access to the platform-specific APIs from the portable library. For example, we could write something like if plugin.connectivity.crossConnectivity current, this is the singleton class, is connected. This property returns a Boolean value that returns true if there is a network connection, and then at this point I can run my code. Additionally, in Xamarin.Forms, I can display messages with a method called displayAlert, which is an async method, and I can write something like await displayAlert, a title such as error, no connection as the message, and a string that is for the cancel operation. Okay. A recent addition to Xamarin.Forms is also the so-called Xamarin.Forms Previewer, which is a tool window that shows a preview of your user interface, since Xamarin.Forms has actually no designer, so this previewer will help you to have an idea of what's going on when designing the UI. So as a recap, in this video we have seen how to create a Xamarin.Forms solution, which includes notions about code sharing strategies based on a PCL or a shared project, and we have seen how the solution is made also of different platform-specific projects, such as the Android, the iOS, and the UWP project. Then we have seen how to design the user interface and how the XAML markup and the imperative code reside in the PCL portable class library project. We have made an overview of how to call platform-specific code from the PCL, and finally we have seen how to run and debug an application on multiple systems, in this particular case with the help of different emulators for Android and Windows 10. Thank you so much for watching this video.